Hello, in this video we are going to learn how to use double angle formulas to simplify trigonometric expressions and equations. So previously we've learned our basic trigonometric identities, our Pythagorean identities, and our even and odd identities. Be sure to have these written down on a note card because they are going to become imperative as we progress throughout this unit. In the previous video, we learned about sum and difference formulas. Remember, the sine of A plus B equals sine of A times cosine of B plus sine of B times cosine of A. Sine of A minus B equals sine of A times cosine of B minus sine of B times cosine of A. Cosine of A plus B equals cosine of A times cosine of B minus sine of A times sine of B. Cosine of A minus B is that same thing except it's an addition. Tangent of A plus B is tangent of A plus tangent of B all over 1 minus tangent of A times tangent of B. And tangent of A minus B is the same thing except the operations are swapped. Make sure that you have these written down on a note card as well because you will need these. Now, this lesson is about double angle formulas. So if we say sine of 2x, that's the same thing as saying 2 times sine of x times cosine of x. Cosine of 2x, one of the options is 1 minus 2 sine squared x. Another option is 2 cosine squared x minus 1. And the third option is cosine squared x minus sine squared x. Now these three are all interchangeable. Sometimes it'll be more beneficial to use one over the other, but in the end they will all give you the same answer. Tangent of 2x is 2 times tangent of x all over 1 minus tangent squared of x. Make sure you have these on a note card or pause the video and take a picture of this so that you can have these to reference throughout the remainder of the unit. Okay, in this example, we're going to use double angle formulas to find the exact, that means no decimals, value for cosine of 2x using this triangle. So we have the angle marked because from this angle we can use our basic trig identities. We know that sine x is opposite over hypotenuse, which is 5 over 13, and cosine of x is 12 over 13. So I can use any of these trig functions, any of these double angle formulas for cosine. I'm going to use the first one in this case, but if you use any that you use will give you the correct answer. So 1 minus 2 sine squared x. Sine squared is 25 over 169. So 25 over 169. So now I have 1 minus 50 over 169. And this simplifies to 169 over 169 minus 150 over 169. So that's going to be 19 over 169. And that is our exact answer. Okay, let's do another example. Once again, we're still using double angle formulas to find the exact value. Same triangle, but this time we're looking for tangent of 2x. So we need to know what tangent is. Tangent is the opposite over adjacent. Remember, tangent is TOA, if you remember that from geometry. So tangent is 12 over, opposite, 5 over 12. 5 over 12. Okay, we're also going to need the squared version of this. So tangent squared is going to be 25 over 144. So 2 times 5 over 12, because just tangent of x right here. We're looking at that tangent of x, all over 1 minus tan squared, which is 25 over 144. So we have 10 over 12 divided by, this is 144 over 144, and 144 minus 25 is 119 over 144. So we have 119 over 144. Simplifying this, that's going to be 5 over 6. 10 over 12 reduces to 5 over 6 times 144 over 19. And 5 times 144 is 720. And 6 times 19 is 114. and that can simplify to 120 over 19. So that is our exact value for tangent of 2x. Let's look at another example, a little bit different. This time, instead of giving you a triangle, I told you that sine is 2 over 3. So we can draw a triangle. If we mark our angle here, opposite over hypotenuse, 2 over 3, we need to find this value right here. So we have a squared plus b squared equals c squared. So 2 squared plus b squared equals 3 squared. So 9 minus 4, 9, this is 9, minus 4, is 5. So b is the square root of 5. So now we know that cosine is the square root of 5 all over 3. We can use any of these formulas. I didn't even have to do all that, because if I would have used the first formula, I only need sine, and I already know sine. So if I would have used the second, now I could square cosine. If I would have used the third, I would have had cosine and sine. So sine squared is going to be, if I square this, it's going to be 4 over 9. So I have 1 minus 2 times 4 over 9, which is going to be 1 minus 8 over 9, which is going to leave us with 1/9. So cosine of 2x equals 1 over 9. And that is our exact value. We have one more example. This one is going to involve an equation like what we looked at in a previous video. So this time we're still going to use our double angle formulas to solve this. So I see that sine 2x is 2 times sine x cosine x. So 2 sine x cosine x minus sine x equals 0. What can we do to this equation? Well, we notice that we have a GCF of sine x, so we can factor that out. Sine x times 2 cosine x minus 1 equals 0, and I can set both of these equal to 0. So I have sine x equals 0 and 2 cosine x minus 1 equals 0. So cosine x equals 1/2. Now, using my unit circle, I can find everywhere that sine is 0 and everywhere that cosine is 1/2, because it's set on the interval 0 to 2 pi, which always tells me to use my unit circle. Sine is our y value, so I see at 0 and 2 pi, and keep going around, I see it at pi. So here, x is 0, pi, and 2 pi. Now we need to look for cosine of 1/2, which is our x value. I see that right here, so that's pi over 3. And I see it, a positive 1/2 is going to be right here, which is 5 pi over 3. So x equals pi over 3 and 5 pi over 3. So combining these answers, I have 5 total answers that make this equation true. And that concludes this video for how to use double angle formulas to simplify trigonometric expressions and equations.